students, welcome to this lecture on hydrocarbons. We are basically discussing the hydrocarbon chapters, and so far we have discussed many important topics in this chapter. In the lecture number 1, we have discussed about the preparation of the alkane. In the lecture number 2, we have discussed the properties of the alkane. In the lecture number 3, we have discussed the preparation of the alkene, and in lecture number 4 we have discussed some of the chemical reactions as being undergo by this alkene and physical properties, and remaining that is chemical reaction that we are going to discuss in this lecture. So heading of today's lecture is properties of alkene part 2. This is K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So in the last lecture, if you recollect that we have discussed about the 3 very important reactions, that is the addition of dihydrogen, addition of halogen, and addition of hydrogen halides or halogen acid into the alkene. And now from the 4th reactions onwards we will discuss. So first we are going to discuss the addition of sulfuric acid. First we are going to discuss the addition of sulfuric acid. Cold and concentrated sulfuric acid can be added to the alkene molecules in accordance with the Markovnikov rules, and it is going to produce the alkyl hydrogen sulfate. So let us have a reaction on this. We are taking alkene, and for understanding how this addition reaction is going on, we are taking the structure of the sulfuric acid. Here you can see our sulfuric acid having the 2 parts. One is the positive, that is the electrophile part, and the negative part. So when we are adding this in the ethene, this is ethene, adding to the ethene, which is symmetrical alkene, there is no problem, that we can easily add it to produce this product. So here you can see this H, that is the electrophile, will add to one of the carbon atom. Now it is 3, and remaining it will be add to this carbon atom. We are showing this, that is OSO2OH, or we can write this C2H5SO4H. So this is the name of this compound is ethyl hydrogen sulfate. Ethyl hydrogen sulfate. Now we are taking another alkene, that is propene. Propene, when react with this sulfuric acid, this is going to produce this. Here you can see this addition reaction is as per the Markovnikov rules. Here this negative part will join in this carbon atom. Why? Because there is a less number of hydrogen atom. As per Markovnikov rule, that where there is a less number of carbon atom, hydrogen atom, in that carbon atom this negative part will be joined and the other part will be electrophile H plus ion will be joined. So we can write this is and O, so to OH and CH3. This is the addition reaction. Total molecule is added into this alkene in a splitting. In the H plus, it is a, basically you can see it is electrophilic addition reaction. So the product here it is produced, that is propyl hydrogen sulfate. So majority of reaction what we are finding that in the alkene is the addition, and that is also the electrophilic addition reactions, because the alkene have one double bond. In that bond, one pi bond is going to contribute and make this alkene as a very reactive, because it is a loosely held electrons which is contributing all those reactions. It will attract the electrophile, and there is a different type of additive reactions you can see. Now fifth number of reactions, that is reaction addition of H2. Addition of H2. Right? So this reaction is basically carried out when in presence of a very small drop of sulfuric acid or acid, because this will going to dissociate the H2 into the two parts H plus and OH minus, and this again there is a addition as per Markovnikov rules, and we are taking this alkene this name of the alkene is 2-methyl because there is a methyl group in that chain. This is a chain, in this chain there is a methyl group, so 2-methyl in the 2 position, 1, 2, 3, 2 position, so 2-methyl propene. This is the name of this hydrocarbon, that is name of this alkene, and when it is being added, H2 in presence of small amount of H plus ion, what is going to happen? This addition reaction is going to produce. This is basically alcohol has been produced. This is OH, CH, CH3. So OH is added in that carbon atom because this carbon atom highly substituted, that is 2 methyl groups substitute the 2 hydrogen atoms of this carbon atom. So it is going to produce this, and this is name of this product is 2-methyl propane 2-ol. Because we know the all is because of this OH group, hydroxyl group. 6th number reaction that we are going to reaction, that is the oxidation reaction. Oxidation, there is a 2 type of reaction we observed. In aqueous solution, and the cold aqueous solution of potassium permanganate, it is going to produce different types of product. When there is a acidic potassium permanganate and potassium diarcomate. This also going to define type of product that we will see. We have taken ethane, and dilute KMnO4 273 Kelvin, means at a very low temperature, 0 degree temperature, this reaction is carried out, and it is going to produce the vicinal glycol. Here you can say two OH group incorporated in the structure in the two carbon atoms, and this is the product is 1-ethane. This product name is ethane 1,2-diol. So this product has been produced with presence of this dilute KMnO4, and this is also called the Bayer's reagent. This is also called the Bayer's reagent. Dilute, this is called Bayer's reagent, and this has a very wide implication, that is it will produce the ethane, or we can name it, that is a glycol. Again we have taken another alkene, that is CH3 CH CH2. It is the propene. Propene, again when it is oxidized in dilute KMnO4, dilute KMnO4 in the same condition, what is going to happen? It is again going to produce this product. This product is, name of this product is propane. This is propane 1,2-diol. So in presence of Bayer's reagent, the alkene is going to produce this glycol or vicinal glycol, and when it is in presence of, now the oxidation reaction we are talking about, when it is oxidizes this is 2-methyl propene. This is 2-methyl propene, and this 2-methyl propene in presence of acidic KMnO4. Acidic KMnO4, it is going to produce the propane 2,1, means the ketone has been produced. Dimethyl ketone has been produced. If IUPAC name is propane 2,1, and the byproduct, that is you can see CO2 and H2O. Now if we change the alkene, suppose we are going to take this alkene, and we are taking this alkene. This is but2ene. When we are going to take this, and in the same condition, with the same condition, what we get? We will get the different product. That is, here you can get the acetic acid, 2 molecules of acetic acid we will produce. So in the oxidation part we can see it, the formation of different product we can observe, and that is depend on which type of reagent we have used that has been reacted and going to give the different product. First, in case of the bias reagents, we found that it has going to produce the glycol, and in case of acidic aminophoro dichromate, it is going to produce this reaction, ketone and acetic acid. Now, seventh reaction, that is again a very important reaction, that is a ozonolysis. Ozonolysis reaction. In this reaction, what is there? When the alkene is reacted with the ozone molecule, total ozone molecule will be added to this alkene molecule and it is going to produce the ozonide. And when this ozonide is reacted in presence of zinc and water, it is going to produce, the molecule has been fragmented and going to produce different types of products. As for example, we have taken ethane. Ethane plus ozone molecule. This is ozone molecule, and it is going to produce. Now we are not taking JEE, we are taking propene. So when it is ozonized, it is going to produce this product. So you can see in the double bond with the carbon, two carbons, here two carbons you can see they are in the double bond, and the ozone is added at this position, and this is called propene ozonide. Propene ozonide. And when this propene ozonide in presence of zinc and water, it is going to be fragmented and it will going to produce the two products. One is ethanol and other is methanol. This is ethanol and this is methanol. So ethanol and this is methanol, two types of products. The importance of the reaction is that in a hydrocarbon, the position of the double bond can be easily find out from this product. From this product, we can able to find out this double bond is in that position, unnumbered position. If it is the other position, then product will be the different. That is 8 number reaction, that is polymerization reaction. Polymerization. This is very important reaction because there is a lot of use of this product after this polymerization reaction has been conducted in the alkene. Alkene molecules, when subject to high pressure and temperature and in presence of proper catalyst, the small molecule has been grown, has been going to produce a bigger molecules, very bigger molecules, and this process of production of this from the small molecule to the bigger molecules, bigger chain molecule, is called the polymerization, and this is going to produce different type of products, as for example polythene sheet, polythene bags, polythene other types of uses you can see, or you can see meal carrots or plastic, any plastic cabinets that we day-to-day basis we used to see. This is basically the product of this polymerization reaction. So how the polymerization reaction occurs, let us see. We are taking ethene. Suppose there is a n number of molecules of the ethene and it is called the monomers. The small molecules from which this bigger molecule is going to produce, it is called monomer. And under a proper temperature and pressure has been maintained, and there is a catalyst has been taken, proper catalyst, it is going to produce the polymers. This is ethene. This is ethene and it is going to produce this. And this CH2 molecule, you can see this CH2 molecule has been joined together and make a bigger, that is a n number of ethene molecule we have taken, and it is that this n number of methyl molecules has been joined together, and it is going to produce this. This is a polymer and this is called the polyethylene. This is called polyethylene. So this has a lot of wide application. You can see polythene bag, polythene sheets that has been used. Another reaction that we can take, CH3 this is we have taken propene, again with the same condition and with the presence of catalyst, it is going to produce this. Here CH3 group will come as a branching. This will become branch and this bond will be opened like this, and it is going to produce this name of this product is polypropene. So from the propene we have produced this polypropene, and ethene, that is the polyethylene. And this has the product is very much very important product. It can be used in producing the bucket, it can be used in the milk carrots, it can be used in others, that is cabinets, that is plastic cabinets of the TV, all those has been produced by this. So that is all for this chemical and physical properties of the alkene, and we have covered all the reaction that is in your syllabus, and that must be helpful to you. We have discussed about the different important reaction, that is the addition of the sulfuric acid, addition of the H2O, then oxidation. Then we have discussed that is the ozonolysis reaction and also polymerization reactions. Thank you for watching this lecture. We will meet in the next lecture with the different topics. Thank you.